I'm Michael Staib, and last year we started the work of creating a new open GraphQL federation specification under the GraphQL Foundation and free to adopt by anyone. We have the hope that this will allow for interoperability between vendors and also just open source projects. Today I will give you some updates of the progress we have made so far. The feedback we got last year from open source developers, from companies that were working in the GraphQL space was phenomenal. There were a lot of people that just wanted to get started implementing this new spec. But late last year, engineers from Apollo, from ChilliCream, from the Guild, from IBM and Hasura really got together in earnest to start on this new specification in the composite schema working group. The Composite Schema Working Group is a subcommittee within the GraphQL Foundation, just like the GraphQL over HTTP subcommittee or the GraphQL Working Group and many others. So a subcommittee focuses on a specific aspect of GraphQL. Benji already said that we basically split up the single working group that we had in the beginning into several subcommittees that then can focus on different aspects here. We work in weekly meetings. That's just our working group. Not every has weekly meetings. To organize our work and to discuss specification text or explore certain patterns in the topic of distributed GraphQL as a whole. The new specification we work on is based on Apollo Federation and on GraphQL Fusion. And it has a new approach to, it has a new standards approach towards GraphQL. We want to make sure that this new specification embraces GraphQL patterns and best practices and doesn't force you in building your schemas in a certain way. This allows developers an even easier way to federate their GraphQL schemas. We build on the principles that Apollo introduced so many years back. And we focus on a collaborative approach where the developer designs their subgraphs as a part of a larger whole right from the start. With the new specification, we wanted to embrace GraphQL with all of its facets and not force developers to build a schema in a certain way to work around limitations. This is why we looked at what has worked well with Apollo Federation and what new concepts are out there with things like GraphQL Fusion or Mesh to make it easier to embrace a GraphQL schema as it was intended. Instead of having an untyped field or untyped data that is passed between the GraphQL gateway and subgraphs, we are embracing the GraphQL schema. A GraphQL schema is designed with intent. It forms a ubiquitous language for your business model. If we look at this little piece of SDL here, we can immediately see what it does. It fetches a product by an ID. We call these kinds of field lookups. And lookups allow us to fetch an entity by a stable key. This is an important concept in GraphQL, not only for gateways, but also for GraphQL clients. Entities might have many such lookups, right? You cannot only fetch a product maybe by ID, but also by a name, as long as the name is unique. In a federated architecture, types are distributed across subgraphs, across service boundaries. So a type doesn't just live on one service, but on multiples. In such a setup, having lookups to get the right data from the right piece, from the right subgraph, from the right service is an important tool. The concept of a lookup is also baked into the best practices of GraphQL. We're actually using lookups for a long time. If you use, for instance, Relay, You might know the global object identification specification, which is part of the GraphQL server specification for Relay. With the new lookup concept, we are also embracing these older patterns because node is just a lookup to us. And once you annotated it as a lookup, we will just be able to resolve all the entities that implement node. But we wanted to make sure that we are not only embracing the old concepts, but also newer patterns that will be possible once the one-off directive comes with the next spec version. The one-off pattern allows us now to introduce finder input types. And finder input types are basically structural unions on the input side, something that a lot of you in the community are yearning for years now to have it. So one-off driven lookup field is also just a lookup, right? The difference here is that it has more semantics. And that is where we give semantics now with the new is directive and the new field selection map syntax. The field selection map syntax that the is directive uses expresses how data from the return type, in this case product, relates and maps to an input type and allows us to understand what this field really does. We have taken this very same approach also with data requirements. So how does this work, these data requirements? So think about the following setup here. Let's say we have a product, and this product has four major fields: ID, name, dimension, and shipping estimate. Let's say part of the product lives really on the product service. And there we have name and dimension, yeah? Basically how big this product is that we want to sell. And then we have a shipping service. The shipping service cares really about shipping the product. So we have their shipping estimate field, which calculates how long it takes to ship a product from our warehouse to your home. So a fridge is bigger and more costly and maybe takes longer to ship. So the shipping estimate field needs really access to the product dimension to calculate how long it takes to ship this. So with Apollo Federation, the data requirements were kind of hidden and just flowed along this untyped representation field that we had with entities. With the new specification, we now embrace the GraphQL schema. So data requirements just become arguments on our field here. But don't worry, to the customer, to your consumer of the GraphQL schema, they will just see the shipping estimate field as it's intended. But on our subgraphs, we now express these data requirements as arguments on the field and then provide some metadata to it to mark them as data requirements. All these new directives validate at compile time, and that is also one of the foundations of Apollo Federation in the past, that you have compile time or build time composition. Making sure that cross-service requirements are valid and can be fulfilled. It's needless to say that you could also have a requirement designed as an input object. Like if you have tons of fields, you don't want to have them as arguments. So this specification is still a work in progress. And it will take some time until we have figured out all the bits and pieces here. And the spec is really at the proposal stage. This is the earliest stage that we have in GraphQL, in the GraphQL Foundation when we work on specifications. If you want to use a distributed schema today, there's Apollo Federation. That is a good choice. Or you can use mesh or schema stitching, even if you want to go for other patterns, older patterns, or GraphQL Fusion. So there is plenty to choose from. We in the working group have migration on our mind. So we know that you at some point want to upgrade to the new specification. So we made sure that you can incrementally upgrade from the older specifications like Apollo Federation or GraphQL Fusion to the new not yet named specification. And this will probably be on a subgraph by subgraph migration. With that, if you want to join our working group meetings, you can go to the working group repository, just listen in or really participate here. Also, if you want to see what is happening in the spec text-wise, you can go to the spec repository, and we are happy for every helping hand that joins. With this, I'm done, and there will be many more talks and panels on this topic. So join us. Thank you.